Hello and thank you for joining us today. We are doing a Khan Academy tutorial on divide polynomials by x with no remainders. This is a great intro into polynomials and division with polynomials. Let's go ahead and get started. We have here 3x to the fifth plus x to the fourth minus 4x squared divided by x. Now anytime you have division, I just got an update on Khan Academy. It's all new. Cool. All right, so anytime you have division like this, where you have a numerator divided by a single denominator. Well, I mean, you can do this even when it's multiple terms in the denominator, is you can split it up into multiple fractions. So we can split it up into, actually kind of want to change it. You can split it up into 3 parts because there's 3 parts in the numerator, 3 terms separated by addition and subtraction in the numerator. And then let's go red for the last one. Minus 4x squared over x. So you see here what we kept the same is we kept the denominator the same in each one because that is x. We wanted to make sure that was x, and that was x. The denominator needs to stay the same in each one of those fractions. Now, just as a quick aside, the reason why we can do that is because let's say we have 1/4 and we add this to 2/4. Okay, we know that's equal to 3/4. So see how we could split 3/4 into 1 plus 2 over 4. So this gets split like this and it's equivalent. So 3 over 4, 3 over 4, that's equal. Okay, so you can keep the denominator the same if you split the top up. See, we split the top up into 2 different fractions. That's completely legal in mathematics, okay? So just wanted to point that out before proceeding. Now, do you have to do this step where you split it into, let me get to the, I like the pen better than the pencil. Do you have to split it up into 3 fractions before proceeding? No, you don't. But I just wanted to show it first because I think it's easier to learn it this way. And then I'll show you the shortcut. So now that we have 3 separate fractions, what we want to do is we want to reduce each fraction. So we can kind of, what I do is cancel out. So because there's 1x in the bottom and 5 in the top, we can cancel out 1x from the top. Another way to think of this is anytime you have division of like bases with different powers, that's technically a 1 there, an implied 1, we can subtract the exponent so we get x to the 4th. Okay, but I like just canceling. Okay, we have 5x in the top, 1 in the bottom, we cancel out 1, and we're left with x to the 4th in the top. This one, same deal, we cancel the 1 that's in the bottom with 1 in the top, and then 1 in the top, leaving just 1, and then the 1 cancels out in the bottom. So what's going to be left is we have 3x to the 4th plus x to the 3rd minus 4x. X to the 1st, or you can just leave it as 4x. 3x to the 4th, 3x to the 4th, well, plus, oops, I think we have to put the down button. There we go. Plus, what was it? X to the 3rd, x to the 3rd, go down again, and then minus 4x. And we're going to check it. All right, next question. Okay, now I showed you how to split it. Now we have 2x to the 4th minus 3x over x. So we can split it if you want. 2x to the 4th over x minus 3x over x. Or, okay, that works. Or what you do is you just take turns. So you take turns doing this and reducing that one, and then you take turns doing this. Because technically you apply this division to both terms in the top. It's not like you do, let me show you that, and then I'll show you what a common mistake is. I don't want to confuse you. So 2x to the 4th divided by x, what we're going to do is we're going to cancel that x with one of those, and we're left with 2x cubed. Let me do the red now. We have minus, let me erase this because we haven't done anything to the denominator with the second term, minus 3x divided by x is just going to give us minus 3. Okay? Now, a common mistake that I see, let me rewrite it, 2x, man, that pencil kind of sucks. I mean, stinks. Sorry for saying that. But they should really make that darker. Okay, 2x to the 3rd minus 3x over x. What I see a lot is students go, okay, I canceled this x with that one, so my final answer is 2x cubed minus 3. That's wrong because you're canceling out this x when it should also be applied to that term too. That'd be like saying 1 over 4 plus 2 over 4, okay, is equal to 1 plus 2 over 4. That'd be like saying I can reduce this 2 over 4 with that, and then that gets reduced, and you're left with 1 plus 1 over 2. That's 2 over 2. 2 over 2 is equal to 3 over 4? No way, that doesn't work like that. So you have to apply that division to every term in the top. You can't just choose which terms you apply it to, okay? So you have to apply it to every term in the top. So don't look at that. That's bad. Okay, instead, 2x to the third minus 3. 2x to the third, 2x to the third, back down, minus 3. Oops, almost didn't see that. All right, onward it says, okay, we have division here, and we're divided by x, so we're going to cancel from each one of these. That's going to become cubed. Okay, go to the next one. We're going to cancel one of these. That's going to become squared. That cancels with that x. And we're going to go to this guy. It cancels that. It becomes 1, or just an implied one. Just leave an x, and it cancels with that. So I wish I could zoom in, but you can see that I've used 3 different colors to designate that I've canceled this 3 times, that x 3 times, leaving me x to the third power, x to the third power, plus 5x squared, plus 5x squared. Oh, I can just use that. Wow. Plus 3x. You don't need to put to the first. You can just put plus 3x. All right, next question, last one. Okay, and I'm going to just do it right from here. So we know we're going to be canceling x, 1x in each one of these terms in the top. So it's going to be 3x to the third because it gets reduced by 1, minus 6x because it goes from x squared, divide 1x, it cancels 1, x to the first, and then minus 1. X divided by x is just 1, so that becomes that. Okay, so as you can see, we had a progression. We have the success, but we had a progression from separating it to 3 different fractions or 4 different, whatever it was, and then progressing into we can just cancel visually. So I hope you found this helpful, and I look forward to seeing you next time on Wes Explains Best.